of all these approximation rules that we're learning, Simpsons rule is the one that gives the best results. It's also the most complicated. But let's look at what it does. Simpsons rule, instead of just drawing the top from the midpoint or using the top of a trapezoid, what Simpsons rule does is it draws in a section of a parabola. And the book goes through the derivation of that, but when you put in a section of a parabola there for each one of these, it gets really close. I think in this example it's going to be exact, but in general it gets really close and it's a good way to approximate an integral. Let's look at the formula for it. Formula says that the approximate integral using Simpsons rule, that's what they're calling S sub n, is delta x over 3, so that's the width of the different intervals, divided by 3. And then instead of just multiplying by the sum of these different values here, they're multiplying each of these values by 1, then 4, 2, 4, 2, 4, and then 1. And it says n has to be even. That's to make sure you end on a 4. And the width is the same as before. So what I want to do is, first I want to do an example of this by just approximating the area under here. Now remember, this was the integral from -3 to 1 of x cubed plus 3x squared dx. So let's work this one out using Simpsons rule. We've got these x zeros and x sub n's. What those are all the places where your intervals start. So in this case, I'm going to blow this up big. This is my x0, this is x1, x2, up to x sub 8. So we've got to figure out what those different values are. Now we know x sub 0, this is at -3. X sub 1 is -2.5. We saw before that this was, the width is 1/2. x2 is -2, then -1.5, -1, -0.5, 0.5, and then 1 for x8. 1. So those are the numbers we have to plug into the formula. So let's come down here and look at this. For this problem here, we've got n is 8, delta x is 1/2, and if we didn't have that already, we could calculate it by doing b minus a, so that's 1 minus -3 divided by n, divided by 8. So yeah, you get 4 over 8 is 1/2. So delta x over 3 is going to be 1/6. So in order to calculate this, we'd have to do 1/6 times, let's see, 1 times f of -3 plus 4 times f of -2.5 plus 2 times f of -2 plus 4 times f of -1.5, and then you just keep going with this until you get to the end. Now, it wouldn't be that much trouble to work this one out by hand, but a much better way to do these things is to use a spreadsheet. So I'm going to pull up a spreadsheet and we're going to do this with it. All right. So I'm going to, let's see, I think I can get both of these on screen at the same time. My spreadsheet a little bit bigger. All right. So here's what I'm going to do. My first row I'm just going to use to keep track of what's in each column. So let's see. First off, let's put I, then x sub I, then f of x sub I, then the multiplier, and we'll fill that in. Okay, so my i's go from 0 to 8. So I could come in and, well, let me just say this. They go from 0 to 8 from there. So I could type in 0, 1, 2, 3, 4, 5, 6, 7, 8, and that wouldn't be that much trouble. But it's much better to use a formula. So this is 0 equals 1 plus that. And so I need to go down to 8. Okay, now these are my x sub i's. For when I is 0, we've got this negative 3 here. And notice every time we go from one x sub I to the next, we're adding a half. So I'm going to use the formula to do that too. So I come to this cell, I press equal to tell it that I'm putting in a formula. Then I do 0.5 plus, click the guy above, and enter. And now I can select this, copy it, and paste into all of these, and it'll give me all the rest of my x sub I numbers. Okay, f of x sub I. In this case, I've got to put in my function, which is this right here, x cubed plus 3x squared. So for this, I'm going to do this is equal to this thing cubed plus 3 times this thing squared. And it's offering to autofill, but I don't want to do that just for demonstration purposes. So if I copy this, then I paste here, notice it changes. Up here it's using B2 for my x, but down here it's using B3. So it'll go down and give me the evaluating the function for the corresponding things in this column. Now the multipliers, those are the 1s and 4s and 2s. So they always start with 1, and then 4s and 2s alternate until you get to the end, and at the very end there's a 1. All right, so if I take all of this stuff and multiply it out, I'll do this is equal to this times that, and I'm going to go ahead and autofill this. So what I've got in this column right here are all of these things worked out. So what I need to do now is sum these guys up and multiply by 1/6, then we'll have our answer. So I can type in sum of, open parentheses, and then I'm just going to select these. And let's see, something I undo. Oh, I know what it is. I've got to type equals sum, and then come up here above. And so that's my sum inside of here. So if I take this and multiply it by 1/6, I'm just going to do that below here. This is equal to that times 1/6. Gives me 8. So it evaluates the integral and gives us 8. So that's kind of a long walk to get to the answer, but that gets us the approximate integral of this right here. Now I want to do several more examples of this, and we'll do those in the next videos.